All right, so last time we left off page 43 on Usain Bolt here. This section on unit conversion has four more pages of homework. I vote we don't do all of them so that we have time to cover the other sections. So let's pick out like every third one or so. Number 49 here. All right, we're doing unit conversion. I guess we should get our conversion tables again. Let's see. Here's one. I'm going to need this guy. Let's start a new page. That guy and this guy. There we go. All right. A baby born in the U.S. weighs 3.485 kilograms. Convert this to pounds and ounces so you can tell the grandparents how much the baby weighed. Well, we take this guy, we multiply it by the number 1, right? But we use a smart one. In this case, we're converting kilograms to pounds. So here it is, right here. Since 1 pound is 0.4536 kilograms, that tells us that the number 1 is the same as 1 pound or 0.4536 kilograms. So that's number 1 here. We need 1 pound, 0.4536 kilograms. So the kilograms go away. We're left with pounds. Let's use our calculator here. So 3.485 divided by 0.4536. This is 7.68 pounds. So we're not done yet because they want us to convert this to pounds and ounces. So what we do is we say, well, 7.68 pounds. Well, that's 7 pounds plus 0.68 pounds, right? So we need to convert that to ounces. Okay, so if we take that and we want to get rid of pounds, we want ounces. And there's what, 16 ounces in a pound, I think. It's kind of early, so let's check and make sure. Pounds, 16 ounces, that's right. So the pounds go away. So we have 0.68 times 16 is 10.88 ounces. So we have 7.68 pounds is 7 pounds and 10.88 ounces. That's almost what my daughter weighed. She weighed 7 pounds and 12 ounces when she was born. Any questions about this? Two-step problem?
No, sir.
All right. So let's see. let's just eyeball this one. See if we can figure it out without doing calculation. Football field is 100 yards. Which one is equivalent? 300 feet? Well, there's 3 foot to a yard, so yeah, 300 feet. 100 yards is not 100 meters, because a yard is not the same thing as a meter. Let's see, yards, 9,143 centimeters. I don't know, 9,000 centimeters. It's definitely not 914 meters, because a meter is bigger than a yard, right? So 10,000 centimeters. The meter is made of centimeters, right? So 100 yards is not going to be exactly 10,000 centimeters, because they're different kinds of unit, right? One's imperial and the other is metric. So it's possible this number of centimeters could be. Let's find out. 100 yards. What we're doing? Yards to centimeters. Okay. Well, you can go from yards. 1 yard is 3 feet, and then 1 inch is 2.54 centimeters. Let's do that. We can get rid of yards for feet. Get rid of feet for inches. Get rid of inches for centimeters. 2.54 centimeters is 1 inch. So yards are gone. Feet are gone. Inches are gone. Centimeters. 100 times 3 times 12 times 2.54 is 9,144 centimeters. This one is true. Y'all understand why I knocked that one out right away, the 10,000 centimeters, right? Because yards is imperial. You know, it's not going to be a power of 10 that works with the metric system. So if this was meters, then I would guess that could be it. But since it's yards, you always get a conversion like this, 2.54 centimeters. So you get an ugly number.
Yes, sir.
Let's see here. This one. 55. 4.5 milliliters the dose of medicine each day. How many days would a cup of this medicine last? Well, let's see how many milliliters are in a cup, and then we'll divide that by this number of milliliters per dose, right? Since it's 1 dose a day, and that'll tell us how many days. So 1 cup is, see, we're aiming for milliliters. So let's see what we can do here. Look at our chart. Here's cups. All right, so how are we going to get to milliliters? Well, we do cup to fluid ounces, and then fluid ounces to milliliters. All right, 29.57 milliliters. So we'll get rid of cups for fluid ounces. There's 8 ounces per cup, right? Yep. Then we get rid of ounces for milliliters. 1 ounce was, my memory sucks, 29.57 milliliters. 29.57 milliliters. Cups are gone. Ounces are gone. Converting to milliliters, right? So we have 8 times 29.57 236.56 milliliters. All right. So 1 cup is 236.56 milliliters. So if they're doing this much every day, all right, and we have this many milliliters, how many days would that last? Well, we take 236.56 milliliters times 1 day is 4.5 milliliters. So you can see all we're doing is taking the total milliliters in a cup, dividing it by the milliliters in a dose, and we're going to end up units of days. So we have 236.56 divided by 4.5 equals 52.57 days. So 1 cup gives you, quite a ways, almost 2 months of medicine. How many years old are you if you've lived 1 trillion seconds? Let's see, 1 trillion. Let's see, how many zeros is that? That's 1,000, a million, a billion, a trillion. So that's 10 to the 3, 6, 9, 12. All right, so if we take 10 to the 12 seconds, and we got to convert that to years, get rid of seconds for minutes, get rid of minutes for hours, get rid of hours for days, get rid of days. I know how many days are in a year. So 60 seconds make a minute, 60 minutes make an hour, 24 hours make a day, 365 days make a year. So what do I have here? I have 10 to the 12th times 1 over all of this. So basically divided by 60 times 60 times 24 times 365. I don't know if I can fit this into my calculator. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Divided by 60. Divided by 60. Divided by 24. Divided by 365. 31,709.79 years. So depending on how you calculate this in your calculator, it's going to round differently. Last time I did it, I got an even 30,000. But if you enter it all in all at once, you get the most accurate answer here. 31,709.79 years. A trillion seconds. So, yeah. Think of these people that are trillionaires, right? They're making $1 far faster than every second, right? Every second they're making $10,000. Hopefully they'll give back though. All right, y'all can convert centimeters to inches, right? That shouldn't be too big of a problem for you.
Yes, sir.
Pounds to kilograms. I think y'all can handle that.
Yes, sir.
Let's look at this one. It's a little more complicated. Last year, Daniel donated 1,892.72 milliliters of blood. If a person donates 1 pint each time, how many times did he donate last year? All right, well, let's convert these milliliters to pints. Pints. Well, we have pints to fluid ounces, and then fluid ounces to milliliters. All right. So a pint is 16 fluid ounces, and we got a fluid ounce is 29.57 milliliters. So let's see if we go milliliters to fluid ounces. 29.57 milliliters make a fluid ounce. And then, what is it? 16 ounces make a pint. So 16 fluid ounces make a pint, but 16 regular ounces make a pound. Okay. So milliliters are gone. Fluid ounces are gone. We're left with pints. Let's see, we got 1,892.72. Divide that by 29.57. Divide that by 16. We get 4 pints. So if he donates 1 pint each time, 4 pints, there's 1 pint per donation, right? So
Yes, sir.
donations per pint. 1 pint per 1 donation, right? Pints go away, and we're left with 4 donations. All right. All right, let's use this dosage instructions here. All right. Boom. The child weighs, is age 12, weighs 105 pounds. Let's see, how many milliliters of medicine will she take per dose? One tablespoon. So how many milliliters? We need to convert tablespoons to milliliters. Tablespoon to teaspoons. This is bullshit. Okay. Fluid ounces. Let's see. Tablespoons to cups. Cups to fluid ounces, and then fluid ounces to milliliters. All right. We're going to go to cups, to fluid ounces, and then milliliters. So a tablespoon takes 16 tablespoons to make a cup. So tablespoon takes 16 of those to make a cup. Now we're getting rid of cups. And I forgot what we were doing. Cups. See, cups. We're trying to get to milliliters. So once we're at cups, we go to fluid ounces. 8 fluid ounces make a cup. 8. Go ahead and put flaws. Fluid ounces make a cup. So now we got to get rid of fluid ounces. Exchange for milliliters. I think it's 29.57 7. Yeah. Make a fluid ounce. So now we have our milliliters. So we have 8 times 29.57 divided by 16 equals 14.79 milliliters. Clean up our chart. All right, let's see. Oh, this one's cool. It's got percentages. Let's do that one. So blood makes up 7% of a body's weight. A person weighs 175 pounds. How much would his blood weigh? Both pounds and kilograms. Well, if it's 7%, let's multiply it by 0.07. So we get 175 times 0.07. 12.25 pounds of blood. So to convert this to kilograms, get rid of pounds, need kilograms. And I forget, there we go, 0.4536 kilograms. 0.4536 kilograms make a pound. Times 0.4536. That gives us 5.56 kilograms of blood. Try this one. Centimeters cubed are in a half a teaspoon. So if we have 0.5 teaspoons, now we're aiming for centimeters cubed. This might be fun here. Centimeters cubed. Let's see, teaspoon. It's the only place a teaspoon shows up. I'll have to go from teaspoon to tablespoon and tablespoons to cups, then cups to fluid ounces, fluid ounces to milliliters, and then milliliters to centimeters. Great. All right, so 3 teaspoons make a tablespoon. Tablespoon. 3 of these make 1 of those. Now they got tablespoons. All right. Teaspoons to tablespoons. Now tablespoons to cups. 16 tablespoons make a cup. 16 tablespoons make a cup. Now we've made it to cups. Now we go from cups to fluid ounces. 1 cup is 8 fluid ounces. 1 cup, 8 fluid ounces. Now we go to milliliters, right? 29.57 milliliters make an ounce. 1 fluid ounce is 29.57 milliliters. Wait a minute, we're going to centimeters cubed. All right. So a milliliter, we need to be in liters here. Here's our liters is 0.001 meters cubed. All right. So let's convert to liters. So there is 10 to the 3rd milliliters per 1 liter, right? And then they said that 1 liter, 1 liter is 0.001 meters cubed, right? A liter is a volume, and this is finally the only one that tells us actual length, a length cubed. So 1 liter, 0.001 meters cubed. 0.001, that's what, 10 to the negative 3, right? 1, 2, 3. Yeah, 10 to the negative 3 meters cubed. Milliliters are gone, liters are gone. Now I need to go to, right, it's going to keep going because we want centimeters cubed, right? I need to get rid of meters in favor of centimeters. And I have to do it 3 times. 10 to the squared centimeters make a meter. 2, 3. All right, meters cubed. Boom, boom, boom. Now we finally have our centimeters cubed. It's a hell of a problem, huh? So we got a 0.5 times an 8 times a 29.57. So I'm going to put this on the bottom since it's a negative. On top, we got 10 squared, 10 squared, 10 squared. That's times 10 to the 6th. On the bottom here, we got a 3 times 16. Let's see, and then a 10 to the 3rd. So 10 to the 6th over 10 to the 3rd, that gives us a 10 to the 3rd. Now let's look at these other numbers here. 0.5 times an 8 times a 29.57 divided by 3 divided by 16. 2.4. Oh, you know what? I made a mistake here. I think. Maybe not. Because I'm getting 2.46 times 10 to the 3rd power. That can't be right. I should be getting 2.46. On how I get an extra 10 to the 3rd power here. Okay, yeah.
So should the powers of 10 be the same?
Yeah. See, I forgot about that one. 10 cubed, right? And that's another 10 cubed on the bottom. So I should have 10 to the 6th on the bottom. And there's 10 to the 6th on the top. So there we go. That's where I just forgot about this guy. So yeah, that's 10 to the 6th on the bottom and on the top. So yeah, it's 2.46 centimeters cubed.
Yes, sir.
All right. As soon as I saw the answer, I was like, that doesn't make sense. It's only half a teaspoon, right? It can't be 246 centimeters cubed. That just ain't right. Got to use our common sense, right?
Yes, sir.
All right. Let's take it's only 30 minutes in, but let's take a 5-minute break. We'll take several 5-minute breaks instead of just one 10-minute break today. All right. So come back
Yes,
at
sir.
9:37 will work. Zoom recording. All right, class, y'all back with me?
Yes, sir.
All right, cool. Where were we? Let's see. Y'all had enough of this unit conversion, or y'all want some more?
Can you go over like 2 more maybe?
Sure. Let's see. Let's do liters to centimeters cubed. liters to centimeters cubed. All right. Let's see how we're going to do this. Divisor-Pan. Liters. We're going to go to liters to meters cubed, and then meters cubed to centimeters cubed. So 0.0025 liters. Again, liters here is a volume, so when we convert it to lengths, it's going to be a length cubed. And we found that 1 liter is 0.001 meters cubed, right? 0.001 is 10 to the negative 3. So now we got to convert to centimeters. Get rid of meters in favor of centimeters. We're going to have to do it 3 times though. 1 meter is 10 squared centimeters. So we got 1, 2, 3 meters cubed. Boom, boom, boom. And we have centimeters cubed now. So we got 0.0025. Wait, liters is gone. We got 10 to the 6th, and then over 10 to the 3rd, 0.0025 times 10 to the 3rd. We don't even need a calculator for this one. So that's 2.5, right? 1, 2, 3, 2.5. Look, and I'm forgetting to write my units. Can't be doing that. We got to write our units. We have centimeters cubed, centimeters cubed, centimeters cubed. If I don't write the units, these equalities aren't actually true. You can't have something that's centimeters cubed equal to something with no units. So something with 3 dimensions can't be equal to something with no dimensions. So 2.5 centimeters cubed. That's almost what we had in the last problem. So 0.0025 would be 0.00246 liters would be a half a teaspoon. We're going from teaspoons to tablespoons. 2 tablespoons. Forgot what the tablespoons. 3 teaspoons make a tablespoon. So get rid of tablespoons. We want teaspoons. 3 teaspoons make a tablespoon. So 2 tablespoons is 6 teaspoons. All right, can y'all handle this? Y'all got unit conversion down now?
Yep.
All
Definitely
right.
got it.
So where's our next set of homework here? Boom, boom. Homework, linear graphs. Y'all need help solving these simple equations? We can do a couple. We got to solve for x. Let's add x to both sides. So that goes away. X plus x is a 2x equals 2. Divide both sides by 2. X is 1. Check our work. Plug a 1 in for x. Does this equal -1 plus 2? Yeah. Works out. Should always check our work if we can. All right, let's look at something like this where there's parentheses. All right, let's distribute this minus here. We have 14 out of 5x. This minus needs to be distributed to both of these. So we have a minus 3x. Negative makes a plus, right? So now if we combine, we have 14. 5x minus 3x is 2x. All right, we'll subtract 2 from both sides. So we get a 12 is 2x. Now divide both sides by 2. We have x is 6. Let's check our work. 14 equals, is this true? 5 times 6 minus 3 times 6 minus 2. This is 30 minus, let's see, 18 minus 2. This is 30 minus 16. Yeah, it is equal to 14. Number 8 here. I think a lot of y'all have these down. Some of y'all know what you're doing, but you're kind of lazy, so you miss a parenthesis or do something wrong, even though you know how to do it. So make sure you check your work, all right? And some of y'all still need some work with this distribution stuff. It can be complicated if you're not used to doing it a lot. So let's distribute this 2. We get a 2x minus 6, and we got this plus x over here. So let's see, it's combined stuff. 3x plus 1, 2x plus x is a 3x. All right, if we subtract 3x from both sides, we have 1 equals negative 6. So that can't work out, right? 1 is not negative 6. So there are no solutions. So how would we check our work here? Well, the way I'd check it is, without looking at what I've done, I'm going to rework the problem. You know, some people just look at their math that they did, but if you do that, it's kind of like when you're writing. You know, I used to write like of the twice in a row, and when I'd read it, I wouldn't even notice it because I just wrote it. You know, I'd make the same brain fart. So the way I check my work in math is I just work it completely independently and see if I get the exact same answer. Let's see, 2 times x is a 2x, and I got a minus 6 and then a plus an x. 3x plus 1, 2x plus x is a 3x. Yeah, subtracting 3x from both sides. So yeah, no solutions to this one. Look at this one here, some fractions in there. All right, let's see. Negative 4x. Let's distribute this 5 through. We get a 5 minus 5x over 6. So since this whole thing is divided by 6, let's multiply both sides by 6. So that'll go away. So we got a negative 24x equals a 5 minus 5x. We can add 5x to both sides so that goes away. And we have a negative 19x equals 5. So x is a negative 5 over 19. All right, we could check our work. Negative 4 times negative 5 over 19. This is the left-hand side. Left-hand side. So that gives us 20/19. Now let's look at the right-hand side. 5 times a 1 minus a negative 5/19 all over 6. So 1 minus a negative means plus. See, 1 here is 19/19. So 19 plus 5 is 24/19. So let's see, 5 times 24. 5 times 24. 5 times 24 is 120 19ths over 6. This is the same as 6 over 1. So 120 19ths dividing by 6 over 1 is the same as multiplying by 1/6. So I got 120 over 19 times 6 over 114. All right. Is that the same as this? Well, let's see. Let's break it down. 120 is what, 6 times 20, right? And let's see, 114. So I did 6 times 20 because there's a 20 that I'm trying to compare it to, right? So 114 divided by 6 is 19. So this is 6 times 19. So 20 over 19. The right-hand side is equal to the left-hand side. So this is correct. All right, let's do some more of these. No, that one's too easy. Let's do this one. All right, let's just do some distribution here. We got a 3t minus 21 all over 2. So let's get rid of this 2 down here. I'm multiplying both sides by 2. So we got 3t minus 21. 2 times t is 2t. 2 times negative 6 is negative 12. If I subtract 2t from both sides, 3t minus 2t is 1t. Now I'll add 21 to both sides. That goes away. 21 minus 12 is 9. So let's check our work. Our left-hand side, 3 times a 9 minus 7 over 2. What is that equal to? So 3 times a 2 over 2, that's 3. Left-hand side is 3. The right-hand side, 9 minus 6 is 3. And that's the left-hand side. Right-hand side equals left-hand side. So 9 is correct. Y'all want to do any more of these? We're going to get plenty of opportunity to do our basic algebra in the future sections. So I vote we move on. Let's see. Homework. Find 3 different solutions for the following equations. So remember this guy, there's 2 variables here. So the solutions come in pairs. There's an x and a y. Now one way to do this is we can visualize all the solutions. There's an infinite number of them, and they would lie on a line. So one way to do this is put it in slope-intercept form. That's the way I like to do it. So if we add 8x to both sides, we get this. Multiply through by a minus. All right, now it looks more like a function. So now if we, to find one solution, let's plug in a 0 for x. If you plug in a 0 in, then y is negative 16. So that's one solution. And we can plot it to be down here at negative 16. The y-intercept, right? That's one solution. We can get another solution. Just plug in any number we want for x. What if we plug in a 1 for x? Right? x is 1, then y is negative 8 times 1 minus 16. That's a negative 24. So at 1, we'd have to go down to a negative 24. So this is a point on our graph. What if we plug in a negative 1? If x is negative 1, then y is negative 8 times a negative 1. Looking at this right here, minus 16, that would be 8 minus 16, that's a negative 8. So over here at negative 1, we'd have to go down to a negative 8. This is what our line looks like. Any point on that line is a solution to this equation. What is our slope here? Our slope is negative 8. Remember, that's our rise over run. So whatever point you're at, pick any point to get another point. For every 8 we go down, we go to the right 1. So down 8, going to the right 1. All right, find the x and y intercept. This one. When we put it into slope-intercept form, it's easy to find the y-intercept, right? The x-intercept is a little harder. Right, you got a line here, right? This point, that's when x is 0. This point over here is when y is 0, isn't it? So to find, if we find the x-intercept, right? Let's let x equal 0. If we let x be 0, and that's 0, right? If x is 0, we get a negative 2/5 y equals 4/5, right? We just solve for y. So let's see. To get to the y, let's multiply both sides by a negative 5/2. Why? Because the 5's cancel, the 2's cancel, and the negatives cancel. And we're left with y equals negative 4/2 is 2. So when x is 0, y is negative 2. What about when y is 0? Plug a 0 in for that, we get 2/15 x is 4/5. So to figure out what x is, let's multiply both sides by 15/2. So we have x is, let's see, 4/2 is 2, right? And then 15 is 5 times 3, so 6. So when y is 0, x is 6. So my line here isn't right, but to put the points where they actually go, 1, 2, and then 1, 2, 3, 4, 5, 6, 0. All right, 6, 0, and 0, negative 2. So that's what our line actually looks like. Any questions about this stuff?
No, sir.
What about this one? Find the x and y intercepts. Well, this is the same thing as y equals negative 3, right? 1, 2, 3. That's our line, y equals negative 3. So there are no x-intercepts. There's a y-intercept at negative 3. But there are no x-intercepts. So use the intercepts to graph the line. All right, well, you only need 2 points to graph a line, right? So the easiest two to find are whenever you plug zeros in. Let x be 0. Then we have a 1/2 y equals 3/2. Multiplying both sides by 2, y is 3. So 0, 3. That's 1 point. The other easiest one to find is when you let y be 0. There's 0 in here, right? We have 0 equals negative 1/6 x plus 3/2. So that tells us negative 3/2 is negative 1/6 x. Minuses can go away. Multiply both sides by 6. So the 6's go away, and we have x is 18 over 2 would be 9. So 9, 0. Right there. You got 2 points. We know what the line looks like. Easy peasy. All right. Let's look at this one. Write an equation of a line with x-intercept negative 2, 0. So negative 2, 0. So a line that goes through that point. All right. Well, let's see here. That means when we plug in a 0 for y, we get negative 2, right? How about plug in a 0 for y, we get negative. How about just that? If you, sorry, yeah. So if you replace x with a negative 2, y is 0. Well, if you replace x with a negative 2, we're just saying x is negative 2. That's this line right here. It totally ignores y, right? So it doesn't mention y at all.
Yes, sir.
Does that make sense?
Yes, sir.
This is telling us x is negative 2. I mean, we could pick out another line if we wanted to make it more complicated, but that's the easiest one, right?
Yes, sir.
Let's see. So we can do 13. It looks like it's in depth here. The graph of a line may be represented by more than one equation. For example, these two equations both define the graph of the same line. All right, find the y-intercept for the line with this equation. We want to find the y-intercept, all right, where it crosses the y-axis, right here. We have to let x be 0. So to find the y-intercept, let x be 0. So we'd end up with negative 1/4 y equals 3/2. So now we want to solve for y, so let's multiply both sides by a negative 4. Negative 4 over negative 1/4 goes away. We have y equals negative 12 over 2, negative 6. So 1, 2, 3, 4, 5, 6. It's at 0, negative 6. Find the y-intercept for the other line. Again, we let x be 0. You see y equals negative 6. For which equation was it easier to find the y-intercept? Well, the second one, of course. That's why we like to put things into slope-intercept form.
Yes, sir.
All right, is it possible to draw a line with two x-intercepts? See, that one only has one. This one only has one. How can you get two? You can't, right? Either you get one, or your line is the x-axis and you have an infinite number of them. No. You either get one or infinity. Nowhere in between. All right, moving on. All right, so put these into slope-intercept form and identify the slope. So basically, you want to be able to take any of these xy equations and graph them. That's the goal, right? So one way is to get the two intercepts. The other way is to put it into slope-intercept form. Let's see, we have -1/4 x plus 2/3. So y is 1/4 x minus 2/3. So looking at this, the y-intercept, if you let x be 0, you get -2/3. So -2/3, boom. The slope is 1/4, right? So for every 1 we go up, we have to go to the right 4. Okay, so we go up 1, we got to go to the right 1, 2, 3, 4. So that would be, what would that point be? 1/3, because we're going from -2/3 up 1. So we have +1/3. Sorry, it goes over here. Went up 1, so from a -2/3 to +1/3, and we went to the right 4. Right, this point here is 0, -2/3. All right, so we added 1 to our y value and added 4 to our x value. So is it possible for a line to have two different slopes? No, right? It has one slope. There is one complication here. What if you have this line straight up and straight down? That's where the slope is called, it's undefined, right? But going straight up, the slope would be a positive infinity. But going straight down, the slope is negative infinity. So that's why it's undefined, okay? All right, can y'all graph these, or do we need to go over it?
Can you graph at least one of them, please?
Yeah.
Thank you.
Sure thing. All right. First thing, let's put it in slope-intercept form because it's easier that way. So now divide everything by a -4. 12 divided by -4 is a -3. So if we plug a 0 in for x, y is -3, right? And our slope is 1/4. So for every 1 I go up, I have to go to the right 1, 2, 3, 4. For every 1 I go up, I go to the right 4. Or for every 1 I go down, I have to go to the left 4. Down 1, to the left 4. You got that?
Yes, sir.
And of course, we can always use our graphing software to check our work. So if it's an exam, final exam, you definitely want to check all your work. They'll have plenty of time. Let's do 14. All right, let's aim for the slope intercept again. We got -1/2 x plus 5 halves. Just moving that over here. So now let's multiply both sides of this thing by a -3/2. So these 2's go away, the 3's go away, and we have y equals. So -1/2 times a -3/2 would be a +3/4. Then we get a -15/4. All right. 15/4 is what 3 3/4, right? So if we plug in a 0 for x, we got to go down 3 3/4. Our slope is 3/4. So for every 3 I go up, 1, 2, 3, I have to go to the right 4. 1, 2, 3, 4. There's my line. All right, find the slope of the line through the indicated points. How do we find the slope of the line through these 2 points? We can graph it and then use a compass, right? Or we have change in y over change in x. The triangle means change in. So change in y, we got a 3 minus 5/2 and a 4 minus 7/2. Okay. So let's see, 3 is 6/2 and 4 would be 8/2. Right? So since everything is divided by 2, 6 minus 5 is 1, 8 minus 7 is 1. I'm getting 1 here. So the slope is up at a 45-degree angle. All right, any questions about that?
No, sir.
The change in y. Let's do this one. Change in y over the change in x. So m equals, let's look at the y's here. We got a -3/5 minus 3/4. All right, that's the y's. Now the x's, 5/6 minus a -2. So let's see on the top, if we're going to get a common denominator, we'll have to multiply this one by 4 over 4. So we get a -12/20. We'll multiply that by a 5 over 5. 15/20. We got a common denominator of 20. Now this one, negative negative is a plus. 2 would be 12/6. So we got a negative 27/20 over a 17/12. 20. So dividing by the fraction is the same as multiplying by its reciprocal. What is this? It's an ugly fraction, right? 12 times 27, -324 over 20 times 17, 340. 324 divided by 340 is a little less than 1. Let's see, we can break it down. We can reduce it a little bit. 324 divided by 2 is 2 times 162. So divide that by 2. And that's 81, which would be 9 times 9. On the bottom, 340 divided by 2 is 170. Divide that by 2 is 85. And 85, let's see, 85, we'll divide that by 5, is 17. So I can take those away. Nothing else reduces. I get a negative 81 over 85. That's our slope in its most reduced form. Which of the following lines are parallel or perpendicular? All right, remember, parallel means same slope, right? These are different lines, but their slope is the same. Perpendicular, that means the slope of one is the negative reciprocal of the slope of the other. So let's find out what the slopes are here. What is A? The slope for A, M is negative 1/6. B, the slope is 6, right? So I could tell you that A is perpendicular to B because they are negative reciprocals of one another. What about C? We're going to have to find out what the slope is here. We got 6y equals negative x plus 30. So y is negative 1/6x plus 5. C, the slope is negative 1/6. So A and C are parallel, right? But B is perpendicular to C. Now let's look at D here. We got a negative 12y equals negative 2x plus 15. So y is 1/6x minus 15/12. So the slope here is a positive 1/6. So D is not, it doesn't have the same slope as anything else. Although it's the negative, it's not the same, right? It's not the negative reciprocal. So D is not parallel or perpendicular to any of these others. It's just, instead of negative, it's positive. Any questions about that?
No, sir.
All right, so that's that section. Let's see. Moving right along. Here, I'll be right back. Give me a second. Catch you later. All right, sorry about that, y'all. All right, we're going to use f of x equals 4x plus 7 to answer the following. Evaluate f of -3. Well, everywhere there's an x, replace it with -3. So -12 plus 7 would be -5. So the point on the graph, when x is -3, y, or the output is -3, 4, 5, -5. So right here, -3, -5. All right. Let's get this one. So find x if f of x is 33. So we'll replace f of x with 33. All right, and now we have to find x. So if we subtract 7 from both sides, we get what, a 26 is 4x. So x is 26 divided by 4, which would be 13 halves. So when f of x is 33, we go up here, 33, x would be 13 halves. That's what, 6.5. So 1, 2, 3, 4, 5, 6, and then a half. That's that point. 13 halves, 33. Find x if f of x is 0. What was our function? F of x equals 4x plus 7. Okay. Here's our function. If f of x is 0, find x. Replace f of x with 0. So 4x is -7, so x is -7/4. So the point on the graph, -7/4, 0. So y is 0, x is -7/4. It's somewhere in here. Explain in your own words the difference between the notations f of x and f of 5. F of x is a function, which when you graph it, it's a whole line. F of 5 is one point on that line where the y value is 5. So let's look at the errors here this student made. What's what happened? Copy, paste. There we go. All right, so here's the function, f of x equals 10x minus 7. And they want to find where f of x equals 0. Well, what they've done here is they've let x be 0 instead of f of x. What they needed to do was call this 0 and then now solve for x. All right. So let's use this graph to find the following problem. So f of -2, when x is -2, the y value, we're not going up or down, that would be 0. F of 1, when we look at when x is 1, the y value is like -3 halves. My little girl's smiling at me. Hey, little girl. Here you go. Waking up, huh? There you All right, f of 4. When x is 4, right there, how far do we go up? We're up here. So f of 4 would be 6. And f of 0, when x is 0, we're down here at -6. Now you got the hiccups, huh? So estimate where f of x is -3. So we're talking about the y value, right? So we go down to -3. So there's 2 points here. One is at x is, let's see, right about here. That's like a -1 3/4. And then over here, that's at about 1/2. Now where f of x is 1, here's all the y values at 1. So we got these two. So like at -2 and 3.5. Where f of x is -9, here's -9. There's only 1 point here. That's about at when x is -1. Now where f of x is 0, that's where f of x is 0. You can see here they have them labeled -2, 2, and 3. That's where it crosses the x-axis. All right, so let's pick up next time on page 87 here. And I will see y'all on Monday.
You too, sir. You have a good day.
All right, enjoy y'all's weekend.
You too.
Thank you. Have a good one.